So this is a new topic, and we continue to work on the vehicle system. So in this topic, we're going to look into different kind of EV configuration. Although you all know that EV configuration must be battery and motor, but there's many ways we can manipulate with this kind of arrangement to make the vehicle become really much interesting. So let's see what it is. So before we do that, then of course, you should ask you about what kind of the target question, what you're trying to learn from here, right? Firstly, what do you know what's the major part of EV? I just mentioned battery and motor is a major part. So when you talk about the EV system, what this terminology you can think of, what they are, what's the EV system? If you want to study a new topic called EV system, or you want to write a journal paper called EV system, what will it include? What do you think?
EV system, like as a vehicle as a whole or just EV? I couldn't get the question.
I just say, if I talk about EV system, this terminology, what do you think it should look like? If I ask you to write me a journal paper for EV system, what kind of the topic will you include?
Everything related to electric vehicle like batteries, motors, and how we can optimize their control system and how efficient we can make the charging system. So yeah, it's all about the whole
everything. Yeah, anything you think of that will become the key development for the EV that will be included in the EV system. So basically, besides the battery, there's many other energy storage is the key thing, right? But we don't need to only talk about the battery, because beside energy storage system, there will be something like supercapacitor, maybe hydrogen, or also part of the energy storage system. For some old vehicle, we may have the flywheel as well. So there's other system. So, we also need to understand some of the key equations in electric vehicle design. However, that equation later on to show you what that equation is. Basically, it's from those written law of motion, really straightforward. And then we also look into how we're going to test an EV. When you manufacture EV, when you design EV, you need to think about how to test that. Without testing, your vehicle cannot go to market. You need to go through some kind of approval procedure to do that. So then another item, we need to look into so-called the driving cycle. So that's maybe not. Do you understand the meaning for driving cycle? Anybody heard about this name? Driving cycle? So that's the item we're going to examine you about how that's something related to how to test a vehicle, the operation of vehicle, the operation of vehicle in a city or in an urban or suburban area. So this kind of terminology you may need to understand well. So we'll cover all this content. So the first half here we try to cover in this lecture. The next half we're going to cover next lecture. Firstly, we go for the EV configuration. So I think you all know that the configuration was something like that, including we got some motor, right? Some motor to go to wheel. Between them, there may be some gearbox or some connection. And then we also have something to control the motor, we call it inverter. Some people call it motor drive, how to control the motor. And someone just call it controller. So there's many different names, but they basically to control the motor, the controller, the inverter is the technical name we call this kind of the controller. And then we also lithium-ion battery, if we use battery, right? And then we have the charger. Then the charger we usually have some kind of onboard charger that will be present in the vehicle itself. Because all the vehicle, there must be an onboard charger. So the charger will be there for you just use an AC cable, plug in there, then you can charge the vehicle. The charger inside your vehicle. But however, we do have other DC charger, DC power. You can input DC power directly go to the battery. So the charger will be more look like outside the vehicle. Yeah. In the inside vehicle, of course, we got a lot of other control system, accessory system to control power source, the steering, lighting, anything, and many other things. And more importantly, we have our energy management system. That system is going to manage about all this energy, like energy arrangement. So that's how we work with a basic configuration of the vehicle. But you see, there's so many these components. How we're going to organize them, arrange them. How many of them will be used? Why I say how many? Then how many battery, how many motor, how many controller? That can be something related to our design. So that's why basic component like that, we look into how we configure them. Then for EV system, the E and V, E electric, V vehicle. Vehicle can be ground vehicle, can be commercial, can be air transport. So the vehicle actually, for basic definition of vehicle, can be anything. So that's why sometimes we call it mobility, something are moving. So here, for instance, this one of the picture we show you a typical example for electric rickshaw. How a boat shall look like. You see a electric rickshaw, of course, we do have a motor. Because different type of motor, one of the tandem motor will be this a number of motors add together, become high power, then that will go to a propeller for this must be there. And then we also have a rudder that can also be part of the electronic control. But power will mainly come from the propeller. And then the system, we do have the connection to charge up the battery inside the ship. So we call it when the ship are docking, then we power up the battery. And then the battery, the energy storage system here, they store the energy through the DC connection here. There's some DC switchboard. We connect them up. And then there's some genset. Yeah. Then maybe you need somewhere. In case anything happens and we have no electricity, we can use the genset to create the DC voltage. And then there's the tunnel thruster to control the movement. We're not only using the rudder to do that. Sometimes in docking, we have a thruster to help the ship to move in different manner, easier to dock or to maneuver. And then we got the power assist control to control the power. So that's roughly about how electric propulsion system of the boat shall look like. But you can see that they're all the same. It's just different name or different arrangement. Everything, there must be some charger, battery, and motor. The basic thing. So that's why when we study EV, electric car, you can apply the same design into a boat, probably maybe aircraft. So let's see how the aircraft shall look like. Of course, the many different aircraft. Then you may think, aircraft, can we still use battery for power and aircraft? It depends on how long you travel. Just like the room, right? Then most of them only travel for 20 minutes or half an hour because the battery is too heavy. We cannot charge up too much energy. But we are talking about the future electric aircraft. That could be one of the major development for all the air transport company because we know that emission for aircraft will be too high. So we need to find a way to eliminate or to solve out this problem. So we have difficulty to use battery. So we may have hybrid solution in the future. So then, for instance, we use hydrogen, liquid hydrogen. So this can be liquid hydrogen. So we make some new aircraft, electric aircraft, we use liquid hydrogen, and then go to a fuel cell, become DC conversion system to power our distribution system, become DC. We tend to use DC anyway. We don't like to use AC. Then this system, we can also store it in the battery, or the battery can be charged back to the distribution system. Then we do have this one, we can connect the other type of the load, including mainly control the motor. You see the DC, control motor drive, you see motor drive, and DC the AC anyway, so that will control to the propeller. So basically something like that. And then sometime when the aircraft being docked on the station, then you can use AC to charge the battery. So that means there's multiple ways, just more like a hybrid solution at the moment. At the moment, we have difficulty to use purely 100% electric because the journey cannot be too long. You can do that, but only half an hour because they're too heavy of the battery. So at the moment, we tend to use a hybrid solution. But do you know why we see that? hydrogen? Why not to use other type of fuel? Which fuel do you think will be most suitable for electric aircraft? What do you think? Just now we say you cannot only rely on battery. So we did think about other possibility, right? What do you think, gentlemen? If you design aircraft, design that, what else you can think of? I'm sorry?
Safety.
Safety. Do you think hydrogen will be safe for aircraft? Anyway, I talked to many aircraft manufacturers. They gradually move on for electric version, and they all based on hydrogen. That's one of the key development in the coming decade. Why they use hydrogen? Firstly, zero emission. You can't have any other fuel with 100% zero emission. So that's why they chose hydrogen. Of course, they cannot only rely on battery because too heavy, too expensive. Then hydrogen, you can able to pressurize them or liquid hydrogen, then become a really high energy content. That will be 30 times much better than battery anyway. And then liquid hydrogen have a second advantage. That will be for the cooling. In some of the compartment, you do need to have cooling. Once your liquid hydrogen evaporate, become hydrogen, go to the fuel cell. And for engine, motor, fuel cell, dry system, power distribution, you need some cooling. So you can make your hydrogen for your cooling. So that's one of the reasons they have been chosen to use hydrogen. So that's huge development in here. But the thing is, they tend to use hydrogen. They don't use combustion. Because some people think about why don't we burn the hydrogen for one energy to drive the propeller? They don't like to do that. They intend to use a battery. That means the liquid hydrogen, they will become DC through the fuel cell and then charge the battery. And the battery, they power up the motor drive. Because when we use motor drive, you can use the technology so-called the variable speed drive. This BSD. So this method is one of technology in power electronic. We're able to reduce the power losses, can have high performance to drive the motor. Usually using this method, same as at home when you use an AC air conditioning system, you use inverter AC, that also save energy. But for motor drive, you can save much more energy. You can save up to 3 to 5 times. So that means when we implement the VSD into the aircraft system, we based on battery, we can able to save more energy, much better than directly to use jet engine or to use the hydrogen engine to drive the propeller. So that basically our aircraft system, still a DC distribution system, really similar to a vehicle anyway. So that means if you have done vehicle design, then you can apply the same technology in boat and also airplane. So now then let's go back to our ground vehicle. Basically, a ground vehicle usually have this major component here, including we do have so-called DC link. We link all the voltage together. We call DC link. DC link is also a popular name in here. So DC link, of course, we have the battery, which connect the DC link. Usually the battery, we don't want too many power conversion states because you can use a converter to change the battery voltage. But we tend to use that voltage directly for the battery and also for the motor drive. We don't like to do too many stages of power conversion because that will be efficiency problem. Any power converter, there will be efficiency issue. You can't have 100%, you use 95%. So that means if you're able directly to use the battery voltage to drive the motor or to do the charger, then that will much more advantages. Reduce all the losses. So that means usually the DC link here, we go to the battery voltage. Then you try to do that. That means if your vehicle open up the spec, you see 800 volt. That means that DC voltage for the battery will be 800. Usually that's how we do. Of course, there's still some vehicles tend to use a converter, but not that
I
many.
couldn't get that, like, multiply by 8, you are saying 800 then 800, I couldn't get that.
Usually, we tend to make the DC voltage for the battery, as last week we say, as high as possible. 800 volt will be one of the highest voltage we use at the moment. And this voltage is the battery voltage. Then we'll connect this battery voltage directly on the DC link. So this DC voltage, if we go to vehicle measure it, will be 800 volt. And then this voltage will directly go to motor drive. We don't need any converter in between. Because once you do that, then you'll be able to directly fit in the voltage into the motor drive. You don't need to many state of conversion. That means we will go to select a motor drive. The input voltage will be equal to the battery voltage, your DC link voltage, so that we don't need to do many power conversion. Once we need to change the voltage, we need to have some additional equipment that will be expensive and also efficiency and the power losses. And then in here, we got the charger here. The charger will charge the battery. So that means this charger control the battery, make sure the DC link in here will equal the battery weight, so that the battery voltage is dominant the DC link voltage. So the battery voltage will not vary by too much, only by 10%, but that will be good enough for the DC link. So that means your inverter, the motor drive should be able to work at slightly variable DC voltage. And then for the other computer or this item, they don't use 800 volt that high voltage. We use a smaller voltage converter to change the voltage to low voltage to drive all this computer. ECU is just a computer. And maybe also other converter to change to 800 volt, maybe to 12 volt or 24 volt to the rest of the vehicle equipment. So that's something how a ground vehicle power distribution system shall look like. Ani, do I answer your question? So here will be a list of all these typical components in a vehicle. So for the power source, it relates to the charger. We have a charger to charge the battery. So battery become part of the power source anyway. Then, as I mentioned before, the charger, we got DC charger, AC charger. For instance, when we charge our mobile phone, there must be AC charger. You could plug into here, there's AC. AC go into the charger system to change the DC to charge our battery. So all the vehicle I mentioned just now, they should have a DC charger embedded inside the vehicle. And then for those high power charger, like those fast charger, even though some other, they call it supercharger, they usually will be much higher power. And there must be DC. So that will output will be a kind of DC voltage that will charge directly to the battery. So that means the battery in here, as you see just now, the battery have a connection, connect to a plug outside the vehicle, and then you plug in your DC charger from your station to the battery directly. Between them, inside the vehicle, there's no other conversion. Because it's such a high current, we want to charge the battery directly. So that means the DC charger outside vehicle, AC charger will be inside vehicle. Inside vehicle, we put it on board charger. Of course, some of the system component, like we have a conductive, which is our charger, usually conductive, but we also wireless charger. So just like our phone, we want to use wireless to charge it. But you see, for the phone wireless charger are really close to each other. You can see they touching, although they don't have any metal contact. But for the electric vehicle wireless charger, they are not touching the coil. They still have a separation. Now the coil will be embedded on the ground, and the receiver coil will be inside the vehicle. But do you know the standard, what kind of distance between the two coils? for wireless charger system for a car? Have you done any thinking about that? Wireless charger, what is separation? Do they close to each other just a few or what do you think?
Yeah, that depends basically on the vehicle, like how waste it is from what's the ground clearance from the vehicle. But approximately still there will be like 50-60% efficiency at best.
You all know that the closer the separation, higher the efficiency. Everybody like high efficiency. Like mobile phone and charger really close to each other, right? But for car, it's different. Too close to each other, then you may end with some other problem because your bottom of your vehicle is quite distant away from the ground and be 27 meters. So that means your coil cannot put it under you close to the ground, otherwise you damage it. So you can't just keep moving the coil up and down. You some system when they design it, they got into actuator motor. When they cut the vehicle, they lower down the coil, touching the ground, right? Then they may think that would be something can improve the efficiency. When they finish charging, they use a motor to lift up the coil. Do you think that would be a good design? No, you don't like that. Parking a vehicle, I like it to be convenient. So that means when the vehicle just go to the parking lot, then they start to charge. They can move if they like. And then there's an international standard from SAE. SAE is Society of Automotive Engineer. SAE. That's a very big organization, SAE, which have been issued a lot of the standard for all the automotive equipment. So they do a standard to say what's the separation. So that separation roughly about 15 centimeter, 15 centimeter. That is something like that. That's quite good enough. At least it won't have any damage to your ground or to your vehicle with your contact. Surprisingly, then there's also a standard. I think last week I did discuss about the efficiency for wireless charger. Anybody can tell me what is the typical efficiency for wireless charger for EV? Have we discussed that? Or wireless charger for electric vehicle? What kind of efficiency they have? Do you think will be only 50% or only 20%, 10%, or 100%? That won't be 100% anyway. So what do you think about the efficiency for wireless charger? I noticed too with my student that you are looking for wireless charging. How much efficiency for your coil you can make?
Maybe the maximum can get to the 85 around the 85, but most application is around the 80.
What is the separation?
Separation around 20 centimeters.
Okay. How about yours? I think you did something in how much is the efficiency?
So I didn't get like for the EV charger, but usually we can get 80 or 90 for good design of wireless charger. But it depends.
So recently they want like 90.4% efficiency for transmission.
That's true. You see, the international standard controlled by SAB will be at least 85%. So they're already international standard. So that means if you make anything less than 85, you can't sell in the market. But 85 is quite good, really nice. Because usually many people do not believe the wireless charging can go up to 85, but actually that becomes a standard. That means many people are doing it. And with separation of 15 centimeters, quite a distance actually to the two coils. So that's what we're trying to think about that. And then, of course, for battery, you can see here, we do have the specification. How to define the battery will be the voltage for the battery, and then the kilowatt hour, the energy storage content, and also AH will be the ampere hour about the current rating. So that's also another one. And all the battery will connect it with BMS, battery management system, for the protection. Then in BMS is something really necessary for all the battery system. When you connect all the battery, become a battery pack, you can't just leave it there. You think that would be work. You might have some protection system. Besides the protection for the heat, for the thermal, for the current rating, there's many other protection. What other protection you think will be important for battery pack? Besides the not too high, not too low voltage, and the temperature cannot go beyond or go more high than and lower than certain temperature range, right? What else you need to protect the battery? How about this gentleman, what do you think?
Possibly charging.
Charging.
When you don't, you got all the batteries are going to charge at the same rate, right? So you have to make sure that they don't overcharge or undercharge certain batteries.
That's really true, yeah, because we got hundreds of battery cells inside the pack. You cannot ensure all the cells will operate at the same time of the current charging. Because we don't have identical battery. They're not identical. It's slightly different. That means this battery may charge up to 3.7, the other battery may 3.75, but some lousy battery may go only 3.6. So we don't have any good balance. We may end up with some disaster. I think the other day we talked about total voltage will look good, but individual voltage, some of them will overcharge, some of them will be undercharged. So that means we need this kind of the battery management system to manage each of the battery cell, make sure they are good.
Why do we use different batteries?
We don't use different battery, we use same battery. But even though same kind of battery, when they manufacture them, because aging effect or other parameter or leak gauge, or some of them will be close to this wire, this further away from this cable, it may make the charging rate or the aging slightly different. So that means they may not equal to the same voltage all the time if you put them in series. So that's the issue. Even though a little bit of different, that could be a critical issue we look into. Maybe when the battery is new, the deviation may not be too much. But after a few years, the deviation, even though 10% deviation would be a big disaster. Say 3.7 volt is the standard. Adding 10% make 4.1 volt. Then the upper limit for the battery will be, say, 4.3 volt. So if you continue to charge up, then one of the battery cell may be over voltage. That will be on fire. So that's why we need to have cell balancing. We do some electronic technique to control the battery so that it will able to balance. So we also need to monitor the condition, including just now mentioned voltage, current, power, temperature. And then we also need to make decision how to operate together with the EV, how to operate the battery. If the charging system demand for high current charging, the BMS can say no, can also control the current profile. And then next about the motor drive. So we have a motor drive system to control on the motor. And then that will be how we drive the motor. We also have so-called the variable speed drive method to drive the motor. And we can able to control the torque of the motor so that in many cases, when the vehicle is standstill from 0 speed, we're able to control the starting torque to be really high, really large, able to have really good acceleration. And then for motor selection, then we mentioned last time, we had DC motor, AC motor, some PM permanent magnet motor. And then even though the motor, we got the in wheel, that means the motor and the wheel are embedded together. Out wheel, they separate. And also we can have more than one motor, multiple motor. And then we also have conversion. For instance, we need to have different voltage. At least the battery voltage will be high voltage. But the computer voltage or other equipment voltage can be low voltage, 12 volt. Then we need to convert 800 volt to 12 volt. So we need many conversion. Maybe there's other voltage in the system. So we need a few different conversion. Some vehicles, they also have an inverter provide AC. I think for instance, some vehicles, they provide AC, then you can plug in your equipment in your vehicle. For instance, you put in your computer or put in your home appliance refrigerator there. Another item will be called the super capacitor, which say the capacitor will be super higher capacitance. So high capacitance supercapacitor is something important because you can able to provide high power, high current. They don't provide really high energy, but the current will be really high. So that means during the braking or starting, you can instantly to provide high current to work with your motor. So other component, other accessory component, including the cooling system. You see, we need a good cooling system. Anybody can tell me which component we need good cooling?
Glycol, water.
The system? Okay.
The
Cooling. Okay. I think most of them need some temperature control anyway. But typically, then the motor we need the cooling. The thing is, if you open up the vehicle, say the Tesla, you find that the motor something like more than 200 kilowatt. But the motor is quite small, really small, that kind of size. 200 kilowatt. But if you go to some industrial drive company, 200 kilowatt motor, this size, industrial motor is that kind of size. But of course, we won't use such a big motor in a Tesla. They're 200 kilowatt only that size. Why is that? How they can make the motor so small? What's the difference?
They may be using multiple.
Maybe what?
They may be using multiple motor.
Well, they use multiple motor, but I mean each peak power for the motor already 200 kW. Of course, we try to use two motors. Each one will be 200 kW, and the peak power will be 400 kW, instant peak power. But anyway, no matter 100K or 200K kilowatt, the motor just that kind of size, still really small as compared to other industrial motor drive system. If you go to visit any, for example, water pump for a building, they have a 200 kilowatt water pump is that kind of big size. But similarly, a motor in a vehicle is so small. Of course, we cannot put such a huge motor in an EV anyway. So what they've been doing to do such, they're still using copper wire, right? Copper is copper. The power loss copper is the same. And also for their motor, they use inverter. One key thing, if you use motor drive here, the frequency applied to the motor are using higher frequency. I'm not quite sure you heard about the name called pulse width modulation. Have you heard about this name?
PWM.
Yeah, PWM, pulse. I think PWM is the technique we output from a motor, from an inverter to a motor. That PWM using high frequency, usually in terms of tens of kilohertz. Just like your motor, we ask you to do high frequency operation because the harmonic will be really high frequency. The high frequency even worse. The high frequency you got ethical loss will be even poor efficiency. So for this kind of Tesla motor, whatever motor they use, we have high frequency there, we have high power there, but they're still so small. Mainly because they have to use really good cooling system. You don't mind to use a low, small motor, but you generate the wire becomes thinner, but you generate high heat. Then in this case, if you have cooling system to remove the heat instantly, then you are able to use smaller size of the motor. So that's a kind of the design balance. You either use a big motor without any cooling or with only a little bit of cooling, but you can use small motor, but you use a really nice, really powerful cooling system to cool down the motor. And because your motor is so small, then dynamic performance will be better, the whole vehicle will be lighter. So that's what they do, yes.
I was thinking also about like the weight distribution of like where that, like if we have like a giant like motor and let's say we could fit it in there,
Yeah, yeah.
right? Like I'm assuming like everything that's attached to it.
Good, yeah, that's the point, yeah.
Yeah.
We talk about vehicle is not only a single motor. Cell Today, when we design EV, we don't use single motor. We use distributed motor.
Yeah.
Two motor, at least maybe four motor. So that means, for instance, vehicle, we are talking about 200 kilowatt of power. If you use four motor, each motor become 15, become much smaller. The motor become lower profile. But if you use 200 kilowatt so big, then your vehicle height will be much bigger, higher. So we don't like that. We load higher vehicles, streamline body, so low profile, so that we use distributed motor, each one with small size, and then we use good cooling system to cool it down, so that we are able to use really small motor. Also for battery, the battery as well, sometimes the battery still generate heat, so we do have the cooling system around the battery to reduce the temperature. Not only reduce, but sometimes we use it to increase the temperature. Because for EV, you park in the winter, you park in outdoor, the temperature can go below 0 degrees Celsius, maybe below 10. So in this case, you may need to warm up the battery beforehand. So that means your cooling system, not only to cool down, but also for thermal management, to warm up the battery, even some winter or critical condition. So that will be important. So that means thermal management, no matter if heating or cooling, will be so important. Then you also have something called the air conditioning system. And to control our temperature, you have some, again, variable speed drive, different kind of controller. So VCU is vehicle control unit. That means is so-called the car computer. You control everything. Everything they would go to the VCU to control them. So that means we need to have a different kind of the control. So here, you see a vehicle, we got many sensors, many control system, and many motor. Each motor we got at least 5 to 6 basic cable or wiring connection. And then we got many sensors. The sensor we have the power package and also the output and input. So you can see that there's so many cable. So you see so many cable, hundreds or thousands of the signal and go to VCU will be really chaotic. So that means how they manage the signal, how to process the signal is something we work with. So that means we don't use that many cable, we use just a few cable, but we use campus, so that the campus, I see another term, CAN, campus, able to put all the signal into the same kind of the connection to feed to the VCU. So all the company have their own protocol for the campus, which is able to do all this kind of the signal processing. So that's also quite another area we can work with. A vehicle also have the gear, of course. I mentioned before, the motor itself will be used at high speed. High speed, the motor becomes smaller. But once high speed, then we need to use a gear to reduce the high speed into low speed. We don't use a low speed motor because it's too heavy, too big. So that's why we are using a gear to do the job. So anyway, EV, there should be some gear, but usually can be fixed gear. We don't have to use gearbox to change the speed because we can use VSD, variable speed drive, to change the speed. But it just step down the speed anyway. So that's roughly about all the basic component. And the next thing is to look into the tracking technology. The tracking technology will be the motor and the wheel. We have some different way to connect them. Although in the past, if we have single motor, then we may have a transmission, we may have a differential gear and a shaft, and maybe have clutch, maybe gearbox to do all the connection. But nowadays, we can eliminate all this connection. If you can, even though eliminate all the clutch, transmission, and gearbox, we can connect the motor directly to the wheel. So in this case, we can eliminate many of the mechanical parts. You see, a gearbox has its own efficiency. Transmission as well, shaft, clutch also efficiency. Even I'm not quite sure their efficiency. If each efficiency is 95%, then everything all up together, maybe we lose about 20% of the efficiency. That's the thing we don't quite like. But however, if we use direct joint, direct connection, so this method we can direct, so we have terminological direct. Direct joint. So that means our motor and the wheel are connected directly without any component between them. In this case, we can reduce all these losses, mechanical losses, and also make the system response time become much faster. So that's how we're going to do. And then for the connection, therefore, we come up with in-wheel motor or out-wheel motor. That's supposed to be hyphen here. So in-wheel or out-wheel. In-wheel, that means we put the motor inside the wheel. Later I'll show you some picture how they look like. And then we got the out-wheel motor. Just they still connect them directly, but put the motor just outside the wheel. But sometimes the wheel compartment is too small to put a motor anyway. So there's two kind of the method. Then we can therefore look into the arrangement, how we connect them. So that's the way we try to different way to manipulate the possible connection between the motor and the wheel. You see the first diagram, A, is to say in some vehicle, we have an engine, ICE engine. We just take out the ICE engine, replaced by a motor. That could be really simple way for eventual fitting. So that's how you know, right? Before that could be ICE, the engine, we have a clutch there, and also we got some gearbox here and differential gear to distribute the two wheel. But now that we just replace it. So that's the most basic configuration or early design for new probably for 100 years ago, up to 50 years ago, I'm using this typical design method. And the next thing will be we don't quite like to use clutch and gearbox, then we may be able to use motor. And then we can use fixed gear, just step down the speed. And then the motor itself, we can use variable speed drive to drive the motor. But that's another configuration. In this case, we can eliminate most of the clutch and fixed gear or this unnecessary item. But because we still have one single driving force from the motor, we still need to put a differential gear in here. So that you know, differential. Because when the vehicle say turn left or turn right, the speed of the left and right are slightly different.
Yeah, translates.
Yeah, we have to translate that into two. So you can go to many websites to show you the concept for the differential. So all the vehicle at the moment, they tend to use differential because they have ICE, how single speed ICE become two speed in the wheel. And then another design will be, instead of putting there, they can use the front wheel drive here. Front wheel drive, that means the motor, fixed gear differential are all embedded in the front wheel drive shaft. So that way, another way we can control and develop them. Or instead, we can use digital motor, divided into two motors to control each one of them. So using this method, we will therefore eliminate upon the differential. Because these two motors separately control this left and right hand side speed, then we can set up an electronic differential. The good thing is we can able to have wide range of the differential. For instance, these two wheels, one is backward, one is forward, and the vehicle can do turning, steering. So that's quite a nice thing to it. And then next thing will be out-wheel motor. We tend to use direct drive. So that means then the motor will therefore really close to the wheel. But of course, between them will be just as short distance as possible. But the motor is still too big, you can put inside the wheel, then you put an out-wheel motor. Between them, we still have some fixed gear embedded inside the wheel engine, or some velocity ratio around it. And then the in-wheel motor will be, another design will be put the motor inside the wheel. So in this case, you can eliminate everything. So that means all the connection here will be much improved. If you use linear motor, you can see that no mechanical subsystem in the whole vehicle. Then the design of vehicle, interior design will be much more convenient. You can affect surface in the interior. Then you are able to do this quite easily. So that's basically about 6 popular configuration when we want to work with the motor. Any question up here? I think in the market, there's many different vehicles have different kind of configuration. They all basically based on this 6 plus something else. I do have a homework to you. So you got about nearly 1.5 weeks to finish it. Then basically ask you something like that. One question will be in here. Besides 6 configuration, would there be any other? So basically, in the past, we tend to use a single motor to replace the engine. So this method, you see, we have been using it for many, many years. I think the first time, I think 30 years ago, people have been using this method for the ventral fitting. They use existing vehicle body, ICE body. They take out the ICE and put a motor there. So that's the method has been really, really promised. But nowadays, because we don't need to do that, we don't need to use the old body from the vehicle, then we can just using a new design, using multiple motor system. You see, during that time, we still don't have the VSD variable speed drive inverter. That's why we still need to use this kind of my mouse cannot be shown on here. I have pointer mouse here, but it doesn't show on there anyway. So that means during that time, we are not using VSD variable speed drive, that means electronic gear. We are using mechanical gear. The VSD version are basically when VSD control the motor. We still need to use a fixed gear to change the speed from motor to the differential. So that's the 2 basic design we have. And just now we also mentioned the front wheel drive will be this configuration. So all the motor put on the front wheel. Of course, we do have the rear wheel drive. Okay? But when we do the rear wheel drive, then that means the front wheel we still need to keep the steering. But if we put a front wheel drive in here, then our steering, we can therefore control on the front wheel. And then we can separate into 2 motors. That in here, we can use differential speed to control the steering. And then here will be our in-wheel and out-wheel motor design. So one of the tutorial we'll be asking you will be, so for the propulsion system, we mentioned just now for the 6 topology. So do you think you can sketch rear wheel design for the system? Just now, our example would be front wheel. But if we're now using the rear wheel design, how will the topology look like? Have a quick sketch about to see, we're able to sketch anything? So I assume you only use 2 motors. I think the main difference will be in the rear wheel drive, you cannot using differential speed to do the steering. Then in this case, you still need to use the front wheel for the steering. When you're putting 2 motors at the back, then in this case, these 2 motors only provide you with propulsion, have no control for the steering. So I think the topology will be the same as before, just move the thing at the back. And the next question will be, when the vehicle in the left turn, how's the speed and torque of the rear wheel? So when you go into left turn, how's the speed and the torque component for the two wheel at the back? Actually, this one will be actually appear in our homework. So I won't go through into detail, so try to answer it in your homework then. Basically, will be that's my basic answer. Will be you still need a steering in the front wheel. We just putting two motor at the back, and the speed must be different. Especially go straight line, the speed must be equal. But when you do a left or right turn, then the speed will be slightly changed. Yeah, very simple, straightforward. And then for other configuration, like the energy storage, then we basically have a three very popular energy storage component used in EV. Then there must be the battery, supercapacitor, and hydrogen. Everybody usually mention about battery, but they seldom talk about supercapacitor. Supercapacitor is just a name capacitor, but we have a supercapacitor, much higher capacitance. We use capacitor because we're able to provide high current that will be really useful when we want to change the speed. When we change the speed, we need to have a high current instantly. No matter it's braking or speed up, then the current will increase rapidly. Then we need to get some current from somewhere. Usually the battery have a limited current output or input. We cannot overload the battery. Then we use supercapacitor to provide you additional current. So usually supercapacitor can provide more than 10 times of the battery current. That's how we design them. And of course, we do have a flywheel for energy source, but it only appears in some really old vehicle. I don't see any vehicle today using flywheel. But in another good battery, we call the flow battery. Anybody can tell me what's the flow battery? The last one, flow battery. Flow battery is another technology people have been working on. Basically, use this element called vanadium B2O5, which we're able to charge this kind of flow battery only charge the electrolyte. So that means we charge the electrolyte, we can use just really look like the gas tank, we can fill in the new electrolyte, which finish charging, the vehicle can go. You see, the good thing is that will more look like a liquid form of the energy source, not a solid form. You don't need to swap the battery. And after the battery becomes flat, you just take away the old electrolyte and then fill in the new electrolyte. And the old electrolyte goes to the station to charge up. So that's why we call flow battery. The way flow is all the liquid, that is the electrolyte to flow. The battery itself still has its own electrode, but the electrolyte will be liquid form to help us to do that. So that's why many people may think this could be one of the solutions, because still electric vehicle, still using battery, but we don't charge it, we only charge liquid. So more look like we can use them in a gas station, we charge up the electrolyte. So think about that, look into this area could be one of the big things. But at the moment, the flow battery still really expensive. Secondly, the lifetime, we cannot use them for a few thousand cycles. So that's one of the critical issue at the moment. Today, for the battery, you can use 2,000 to 5,000 cycles, but flow battery cannot. So that's why it becomes too expensive at the moment. But there will be technology development. I think in the near future, it could be a good player.
How many cycle?
At the moment, only about 500 cycles. 500 compared to lithium battery, at least 2,000. So that means you see if you use 500 cycles, that means you can only use for less than 2 years. And the battery cell more and more expensive than lithium ion. Lithium ion already very expensive. You know? So that's why I don't quite like. But however, another way will be for lithium ion battery, you need to put a lot of battery there in order to able to travel for long distance. If you want to travel for long distance, you put more battery. But for full batteries, right, you don't need to put on really high power. And because you can free up the electrolyte. So the battery cell can be look smaller. You have a tank there to store the electrolyte. And then the electrolyte liquid will go to your battery system, the full battery cell.
Much lighter.
Can be lighter. Yeah. So because lithium ion battery is still really heavy. And for the full battery, only the 2 electroplate plus the new electrolyte. So in a way, you can decide to be lighter. Then we have another topology to discuss. That will be according to the energy source. You see just now we mentioned about we have supercapacitor battery, maybe flow battery, many different types of energy source. Maybe even though gasoline or whatever. So that means the arrangement of them have a number of the configuration. The most simple one will be single battery type. And go to a power converter P, which convert to become our DC distribution link and go to the whole system. But and then some people they say I don't like a single battery because firstly, single battery, if in case this one is broken, then the whole system may have other disaster. And why don't we use 2 batteries in parallel? So that will become 2 batteries connected to a power converter. They may think that 2 battery may have some balancing. You don't need to have a heavy weight for certain battery pack. They balance up to become 2 locations. But having said that, but nowadays all the battery design will be, as you see the last picture I showed you last week, you got a large surface of battery at the bottom of car in the chassis. But still they connect all of them together in a single 800 voltage. But you see if one of the cells is broken, will that 800 volt be not working? Depending on the design, they may have some bypass. The voltage 800 volt may become 790, still good. Yeah. So I think the way we design dual battery pack has been one of the history of the development. In the old state, they say they got 1 battery pack, 10 kilowatt. They want to put second one in case anything happen, you can use it. Just like in the old days, when we use our mobile phone, we have a spare battery. In case this battery is used up, then you swap with a charge up that battery. But nowadays we don't have that. So that's one of the development in the history of development. They tend to use a multiple battery. But in a way that will be also feasible. The new design of the electric vehicle, we tend to use so-called configurable EV. The EV can be configurable to different size, different function. In this case, once the EV change the configuration, change the shape, then the connection of the battery may not be so convenient. Maybe this part of the vehicle have a battery, the other part have no battery. But if you use 2 batteries or multiple batteries, you can ensure that each portion of vehicle has an energy source. So that's another way we need to think about how to use multiple batteries. And then another one will be the fuel cell. Fuel cell, of course, will be also look like more promising. So sometimes fuel cell provide DC, that DC is together working with a battery. Fuel cell will provide the DC, but all the fuel cell vehicle must have a battery. Anybody can tell me why is that? The fuel cell vehicle, hydrogen fuel cell, for instance, we must come with a battery. Not one second.
Fuel cell is generating the power and can store it.
That's true. Fuel cell just like AA battery only can generate power, cannot absorb any power. For the vehicle, all the EV you see, you need to power generation. When you brake, when you're going down a hill, you want to power gen. go to the battery. So in this case, we do need a battery for the energy regeneration. Another item will be the fuel cell usually the power rating. The current is not that high. Yeah, so that means in case just now we mentioned you want to speed up overtaking or braking to high current, then you need to use a battery support your instant power. So that's why we use to put a battery there. The next another approach is battery reforming fuel cell. Then sometimes we don't use a hydrogen fuel cell, we may use other type of the system. For example, like methane. Then methane CH4, then we need to use a reforming from CH4, we take out the hydrogen to the fuel cell. So we have a reformer here to do some cracking. And then of course we also together with a battery. And another method will be we can use supercapacitor. As I mentioned before, battery, you can provide most of the power, but sometimes you need a high current, then you can use supercapacitor, provide high current. But these two may not match really well. Key reason is the voltage may not be equal to each other. The thing is the battery we use 800 volt. Then for the supercapacitor, if we use 800 volt, may not be so convenient in the design. Most of supercapacitor, the voltage is quite low. Yeah. The battery lithium ion battery. The voltage roughly about say 3.7, really popular. Some of them may be, although we do have lithium ion battery 2 volt, but most of them will be 3.7 typical. And then supercapacitor. The voltage is much lower, I think 2 point something, usually 2.7. And they're much more expensive. So we usually have difficulty to use too many supercapacitors connect in series. Too expensive, too costly.
What about that, the other option, the the
Flow battery?
yeah, would you be able to like maybe like connect that with with any of the current configurations at all? To like
Flow battery, just like battery.
yeah, it's just
Just
like
simply look like a battery. Then the configuration, for instance, this one, this battery can be a lithium battery or can be a flow battery.
oh, it's just
Something like that. But the thing is more flow battery, more look like this kind of things here. Fuel cell or flow battery, I think flow battery is not really good for recharge. We cannot put a single flow battery in an EV. Flow battery, you can, although it's make a form of energy, but you can only deliver energy to the vehicle, but cannot absorb energy. So if you use flow battery, you still need to put some smaller size of the battery for power regeneration.
yeah.
I didn't talk about the flow battery here, maybe the exam. I can put one configuration, ask you to sketch a flow battery, how you look like. Okay, then we do have supercapacitor here so that we can match up the full voltage here. Because it's too expensive, we cannot use too many supercapacitor cells. And also too heavy. Supercapacitor usually will be at least 10 times more expensive than battery and 10 times more heavy than battery. So we just put a little bit for the current for protection of high current. And then of course we do have flywheel. Flywheel, of course, we put here just for the history of development. We do have in the museum, you can see some flywheel vehicle, but just not really convenient to use anyway. So we store the mechanical energy. We do have a power converter, so the DC you can convert into flywheel just like a motor to drive the flywheel. And the other way, the flywheel can use a generator to generate power. And so that is basically about number of the configuration. So for more detail, I talk about here. So that will battery connector converter, but then battery, multiple battery here, maybe more than one. Then how we pair them up to do the job. Sometimes the battery we can select different kind of the battery. Some of them we can use high energy content, and some of them we can use a high power. Because for battery, you got different AH. Then you can select high H. Then that will be provide you high current or high so-called C rate. High C rate will be expensive, so you cannot use all your battery at high C rate. So to do this one, you may have two battery pack. One will be using high C rate, maybe 4 of the C rate, you're able to provide high current. Another one will be 1 of the C rate, you provide standard power. So that's another possible design. You can also able to work with high current and high energy. So that's one of the ways we can do. And then this one will be, I said, will be fuel cell. Then even though flow battery, you can also use this configuration. Reforming mainly looking into this kind of cracking. We need to crack the methane or other kind of the hydrocarbon into hydrogen. So that means you need to use reformer to crack them, become hydrogen. Hydrogen will go to the fuel cell. Because the fuel cell, we still need a battery in here. And then supercapacitor, one of the important developments, so we usually put the supercapacitor and battery together, become two parallel components to go to motor drive. And flywheel also part of the development because you do need to use generator and motor to drive the flywheel. Usually we need to have this P will more look like a motor. The motor will do two jobs. One is to motorize the flywheel, another one will power regeneration, convert the flywheel energy back into the battery voltage. So that basically will be 6 typical topology. Any question? Yes.
So like choosing between each of these configurations, would we be like referencing like an IV curve for these, like for like each of like the power, like the power storage devices?
I think
So
so.
like judge
Yeah.
like what you should be using.
Yeah, that's really good question. You see, which topology to choose from depend on the cost, and also depend on what your performance look like.
Yeah.
For instance, if you want to do a demonstration for flywheel using mechanical energy, or in your country or in your location, you don't have any battery available, and you don't have any fuel cell available, you may use flywheel. That's also one of the good solutions. And in some conditions, if you really want to have a long range of the development, long range of traveling, you need to use fuel cell. But sometimes fuel cell will be the first fuel cell here based on hydrogen may not be too convenient because some country may not able to get the hydrogen supply. So then you may need to use a reformer, crack the carbon fuel into hydrogen. Then you may need to use that. So this kind of selection, I think, could be due to the availability of the energy source in your particular country. Or of course, it also depends on which design you like to do. Some people only prefer to use pure battery vehicle. They don't quite like to use a fuel cell. Or some of them they like to use combination. So that all depends on a number of scenarios. I don't think there's any fixed answer. There can be anything. And then next section you discuss about the gear. You see, once we got the VSD, variable speed drive, this VSD more look like an electronic gear. You can use electronically to control the torque and the motor speed. That look really nice, right? Now then you come to an issue will be, we are now using a so-called inverter. Inverter is an electronic circuitry, can provide the function, become a variable speed drive VSD. So all the vehicles will have that anyway. The VSD, you can able to control motor speed from 0 to peak RPM. So that is to say VSD will be replace all the gear. So the key advantage will be we don't need to use any maintenance. You see gearbox have a lot of the maintenance. Auto lubrication, auto everything. And then you can eliminate all the clutch. You don't need any clutch. Clutch also not very good. And also all the mechanical loss can be eliminated. As I mentioned before, if a clutch at 5% losses, you lose 5%. And response time will be instantly. Because once we eliminate all the mechanical subsystem, the response time will be all electronic control. The electronic time constant will be much, much shorter. you just more look like instant response when you use VST. So the performance better, so less noise and also highly accurate. Especially when you use the position control, you want to control motor, control vehicle to control the what kind of particular location. Then using this VST, we are able to control the location, the position, and speed really well, much better than gearbox. Gearbox, you see between the gear, there will be some gap. You can't control exactly. But VST, you are able to control them properly. So VST technology in here, mainly we use power electronic control them. We are able to control torque, control the speed. That is a really mature technology. VST has been in the market for more than 40 years. So the reason why we want to give up on ICE or give up on the gearbox mainly about that. Conventional ICE, the torque profile is not really good. So especially at the low speed, the torque or the force provided by ICE is not good. So that's why we need to use gearbox to do the job. So we got first gear, second gear, and so on. So that means in first gear, we are able to use gear ratio to provide higher of the top gear. And then when the gear go to a high gear or over this drive, the amount of the torque will be much lower. So when the vehicle gets speed up or already have the speed, then you can use fifth gear. Then if that comes to an issue will be when the vehicle stands still, you have to use low gear to do it because the ICE cannot provide sufficient torque in the standstill. So that's why we need to change all this curve. We can therefore using VST to replace all this, become single motor to control the torque and speed profile. So once we use VST variable speed drive, then that's the curve how it look like. Firstly, the motor speed here, even though it's zero speed, that means the standstill. Then the force can go up to a flat maximum. You control the whole speed range here, have a constant torque or maximum torque. If you use the ICE, the torque will just start from really low and gradually move up when you pick up the speed. But we don't like that. So that's why if the two vehicles stand still in here, usually the EV will go first. Much faster response time than the gasoline vehicle or ICE vehicle. But so under this region, this point will define the performance of motor at the maximum torque and maximum speed. Our EV is not able to provide maximum torque for all the speed range, but we're able to provide with you large range. Beyond this maximum speed range, then the torque still will go down. But still this range will cover good enough for most of the operation. Only in highway, really high speed, then torque allow the motor to reduce the torque. So that's how we adopt it. But however, for all the EV, we still need a fixed gear. Usually just 5 to 6 times fixed gear, we're able to improve the power, the force for the motor. As I mentioned before, the motor usually high speed. High speed, that means the torque will be lower because speed times the torque with the power. The motor power will fix it. Then if you want to have sufficient kind of the torque, the motor speed will be need to reduce. So we need to use gearbox to do the job. Yeah, so that's really straightforward. And then VST, it become gearless, right? So we don't need to use that. Then we can the key thing will be second item, zero speed torque. Even though standstill, we still have a high and constant torque over a wide range. So the torque only reduce at high speed, but that won't be any concern because high speed, we have less demand for the torque anyway. So that's why EV have a high acceleration because we got high torque, high standstill torque. In the standstill, you're able to use peak torque to speed up the vehicle. So that's why we got really good acceleration for the EV. So for 0 to 100 km, the acceleration time you use much better than ICE. So that's, I think last week we talked about the specification for 0 to 60 mile or 0 to 100 km. Most of the good EV only just a few seconds, 3 seconds, 3 point something seconds. That's a more reasonable because all the EV able to use powerful motor to do the job, but not all the gasoline engine. So I do have a homework to you. I think you should check the homework. One of the questions I discussed with you last week will be what's the maximum acceleration for electric vehicle? Would there be any limitation? Would that be 0 to 100 km? Would be less than 1 second. Would that be possible? So you try to take out your understanding in here. So because we're able to use high starting torque, even the energy will be saving quite a lot because we don't need to push the ICE to a really extreme case. To use motor, we can simply to use torque control. We're able to provide high torque performance without too much energy input. So that's a nice thing for the motor can do. But you see a system, we may think of to use multiple motor. I think for the topology or configuration we discussed just now, we do have a single motor, 2 motor, or maybe 3 to 4 motor, depending on your configuration. Then in this case, for example, like differential gear like in here. So this is picture, you can go to this website to understand the basic principle for differential. Because in the past, we only have single driving force, we need to use differential. So the concept is quite straightforward. It's also really important development for automotive. Without that one, the vehicle have a difficulty to do the steering and turning. But now then, when we have electric car using electric motor, we can use motor to replace the differential. So in here you say when you do right turn and left turn, the speed or the torque for 2 motor are different. So we can use the VSD to control that quite easily.
So this is basically like the, I guess like the turning. I don't want to say signal, but that's the closest thing I could describe. Like I guess like the turning signal is now done electronically between the motors instead of mechanically between the gears.
Yeah, you see the differential we got the driving shaft. We got the motor, we got the ICE connected. One single motor. Then when it goes integrated with the 2 left and right wheel, then they are able to have different speed between the left and right hand side. That's a concept for differential. Then when we use 2 motor, then as you see, we just control the speed and torque for the 2 motor on the left and right hand side. Then we can actually replay all the function for that. Once we distribute the motor into 2, we can lower the profile, can make the weight balance to be more balanced along the whole vehicle, rather than the whole heavy item in the center of the vehicle. Now ICE, we got very heavy engine, then at certain location, then it's not quite good, right?
And I would assume that the response time would be like a lot faster with electron. Yeah.
You see, when you use this kind of mechanical connection, when you control left and right speed to the certain requirement, the response are really, really slow.
And it's not perfect either, right?
No,
Yeah.
that's true. And then with 2 motor, we can instantly, you see the motor time constant will be much faster in terms of the millisecond, a few milliseconds. Within millisecond, we're able to change the speed quite instantly. Yeah. But for differential, I guess the time constant will be tens of milliseconds. I'm not quite sure, actually. I feel at least tens of milliseconds, maybe 100 of milliseconds. So that means response time will be slow. So that's why when you use electronic here, this kind of electronic differential, that means 2-wheel motor system, you can do the steering really, really quick. So that's why if you want to perform the anti-lock braking, then differential or using this, no matter 4-wheel drive, the ABS still not really promising. You see anti-lock, that means under the skidding, maybe in the slow oil surface, then we need to control the brake. To change them in high frequency braking, 20 hertz on, off, to eliminate the skidding. Then that is to say we usually using a hydraulic pump system to control that ABS. That will be a disaster. And also each of the wheel we need to control individually about the ABS. That will be really difficult for mechanical car or for hydraulic control system. Then when you use electronic brake, I can control each of the motor individually. Each of the motor, we can control brake individually. So in this case, ABS, I can able to achieve for each of the wheel independently. So that means using the electric vehicle, you are able to do that. But however, at the moment, all the electric vehicles, they are still using individual motor. But motor only for propulsion. The braking, they only for jump braking. But they haven't implemented the anti-lock braking into each of the wheel. Anti-lock braking, you need the 20 hertz of the braking pulse. They haven't done that yet. So you need individual braking, small ABS braking motor to control that one. So not many companies have done that. So that's another new technology for the future ABS development. Do you know the difference between just a motor, traction motor, which gives you the traction power, give you the power generation. But for ABS, we need to control the braking. In case any skidding, we need to vibrate the braking pad so they're able to resume the braking, pick up the braking. That's another technology. So with the vibration, so that they're able to pick up so that the wheel will not be locked. At the moment, once hit, the wheel becomes locked. We need to use 20 hertz, with 15 to 25 hertz to unlock the wheel. That is not only the motor now, there's an additional braking motor to do the job. In the past, we only use hydraulic to do that, but hydraulic is too slow response, not able to do everything. We cannot control each of the wheel to that individual performance. So that's another technology. If you go for my next course in electric, our more advanced level for electric vehicle, you will learn how to do the ABS. Here, this is actually only very simple electric vehicle discussion. So even though Tesla vehicle, they don't do this high performance ABS, they still using certain hydraulic system to do that housing. Interesting. I'm the first one to do the 100% ABS. If you look at my journal paper, I already published a number of papers in all electronic ABS. Anyway. So, yeah, so that's how we talk about the differential theory. Right? So differential gear, mechanical thing, they have one shop here, different differential gear, separate the two, they got two kind of speed and torque, especially useful when you do the turning or we try to maneuver the vehicle along a road. The road may not be even, so the two wheels are not in exactly the same speed and the torque. So we have to use differential to do that. Conventional mechanical differential can do the job, but not really nicely because you can't have a really good control, really good variation for the motor, for the wheel speed. But that's the technology 30 years ago. But now then we use differential motor, then we can change all this. So we can use two motors like this, each a motor. We can control torque and speed, whatever we like. So that's why we're able to control the vehicle nicely. But of course, the advantage is here. But the disadvantage will be you need to have two motors, but that won't be a problem. The motor is really cheap, really low cost. You can also use distributed motor. So actually, today we prefer to use two motors to lower the profile. And then you need to use two separate control to two motors, and then you need to synchronize them, make sure they can synchronize to your control speed method. In case your control not really well, your vehicle cannot go a straight line, right? As I said last week, it's really simple control method. We have done that 30 years ago. No longer a problem. When I go to many conferences, many students or many professors ask me, can you do that? You use two motors to control two wheels? Can you make sure they go straight line? I told we have done that control 30 years ago. It becomes simple technology. So simple. So don't worry about it. So that's why today you can all see all the vehicle, they're using two motors. no vehicle, new manufacturing, they use single motor. We don't like that. So that's why that's a really simple technology. And if you come to my advanced level for EV, I show you how to do that. Anyway, so that's the technology. We are using two motors to control them. So that means we do have a number of advantages to use multiple motors. I think here we list out all the advantages we have been talking about. So you can think that in the future, many vehicles started to go for two-wheel drive, maybe four-wheel drive. You see this four-wheel drive, 100% four-wheel, totally four-wheel drive. Not the other vehicle, if you go to buy Subaru, they all say they are four-wheel drive. The thing is they use single engine. How can they do 100% four-wheel drive? Impossible. Then you manipulate a little bit. But our EV four-wheel drive, the 100% four-wheel drive, still to top speed also can manipulate the speed, right? So that's what we're trying to do. Independent control and low profile can distribute the weight, distribute the speed for the vehicle, improve safety. You see, when we use four-wheel drive, our control system will be like that. Even the one wheel is broken, we still have three wheels to control vehicles. The vehicle won't go to disaster. Just like airplane. Airplane usually have four engines. When you know that four engine there, one engine broken, the pilot can still control the other three engines behind the vehicle, behind the aircraft. The same thing will be on this. We can still bind it. So that means using four-wheel, we can improve the reliability. In the past, if you use single motor, if the motor is broken, you can't do anything. But now you have four motors. One broken is okay. Two motor broken is okay. Three motor broken, yes or no, but still higher reliability will be here in the EV. Then we use two-wheel or four-wheel.
So where is like the development of this currently? Like I guess. So you said that like companies like Subaru, like they say that they claim that they're using four-wheel, but it's not true four-wheel. So like where is like what?
Because they're mechanical car anyway, like the Subaru four-wheel drive, all-wheel drive. The mechanical car, how can make sure each of the wheel can be 100% controlled from 100% all-wheel? Impossible. Mechanical can't do much about it. The response time is so slow. How under the skidding, how can you control that perfectly? But still better than many other scenarios. So that's why we do promote to use four-wheel, 100% electronic four-wheel drive. That's the way we need to go forward. You see, in the uphill, downhill, uphill turning, downhill turning, then the demand for the four-wheel drive will much higher. You see, when you go uphill, the rear wheel need to have higher torque, and downhill will be the other way. And then when you do the turning, then the balance between the torque also quite complicated. And then when we have a vehicle control system, we'll balance all this torque control for each of the wheel so that you move nicely on the road surface. And so that means in the future, when we design vehicle in autonomous driving, we need to implement all this into the vehicle so that you can able to self-drive under all the scenario to be safe and high performance. So that's what we're trying to do, so-called high dynamic performance. Once we use four-wheel drive, all this high dynamic performance in terms of all the scenario we talked about just now will be here. So to summarize what we're trying to talk to today, you see we talk about what is meaning for high performance vehicle. We basically looking into the EV design. Motor drive is one of the critical things for all the motor drive system. We are able to control the motor individually or simultaneously or synchronized manner to control them. So that depends on how we configure the whole EV configuration. We mentioned just now we got different configuration for the motor, different configuration for the power source. So this tool will give you how the variation for design you're going to do. That design depends on your application, depend on your material available, and depend on how you would like to connect them, highly related to efficiency and also the power. So topology is quite interesting, but it's quite straightforward. When you see my picture, then you can see that is the topology can be available. You yourself may think of other new topology, new arrangement, how to combine one to the other. For instance, I say we basically think a motor vehicle must be either two-wheel or four-wheel. How about if you want to design three-wheel? Can you design a topology for that? That will be quite complicated, I'm not quite sure. So that's the question will be in the homework. Think about that. So that's something you have to, for instance, in the future, when you join Tesla, the boss asks you, can you design EV for me? I only give you free motor. Design a new topology. Then that's your job to think about how to do that. So that's why we need to study topology, because like that. And then once you decide that, another question will be, let's allow the interference from your motor. For some motor, we use USB. Then we have pulse width moderation that generate a lot of the high frequency pulses, like the 20 kilohertz, 600 kilohertz. That's the thing happening around the whole vehicle. The thing is the power component, the high current, all the high frequency appear in the whole vehicle. How are we going to design the DC bus to eliminate all this noise? The noise is another big problem, because not only the motor, we are not using DC pure current to drive them, it's a pulsational current, so that causes you a lot of noise. When you design a motor, when you distribute the motor, the problem will be everywhere will be noise. Before you have single motor, this location has the noise, and now you have distributed. Each corner has high frequency along the distribution. So how are you going to eliminate this? But the people saying that you need to use distributed motor. So that's something is happening in design, how to protect each of the scenario. So that's why we also talk about differential gear. So now we play by this new motor. And later on, we'll talk about the force mode motor in next week then. So there's some reference. If you'd like to see more, you can go for it. Any question before we go away? Very good. Do you like my lecture, or do you like this kind of the content? Or do you think it's too simple or too difficult, or just like good? Thank you then. Okay, see you again next week. I'll try to put the video on the website if I manage them. Then in case you want to review in the future, you can also do that. Okay, see you again next week. Do your homework. You got nearly 2 weeks to finish it. All the homework have no fixed answer. Any answer will be good. All right. Thank you then. See you.